Hi guys, welcome back to Anjali's Math Desk. In today's video, we will be starting with a new topic of squares and square roots. Let's first talk about the area of a square. What is the area of a square? It is side times side. Let's say we have the measurement of the side of the square here. We will determine what will the area of the square be depending on the measurement of the side of the square. Let's say the side measures 1. The area will be 1 times 1 equals 1 square. Let's say it's 2. It will be 2 times 2, which is 2 squared, right? And if it's 3, it will be 3 times 3, which is 3 squared. If it's 4, it will be 4 times 4 equals 4 squared. So on and so forth. If the side was A, centimeters or meters, whatever unit of measurement we have, let's say if it was A, the area would be A times A, which is A square, right? Now, let's talk about what are square numbers. Numbers that can be expressed as products of the number with itself are called square numbers. So what are square numbers? Square numbers are the numbers that can be represented as product of the number with itself. So numbers that can be represented as product of the number with itself are called square numbers, right? Examples: 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. These are all square numbers, and we can keep going. So generally speaking, we can say if a natural number A can be expressed as B square, where B is also a natural number, then A is called the square number. Now let's talk about the properties of square numbers. Let's look at all squares of numbers that end with digit 1 or 9. Let's look at all squares of numbers that end with digit 1 or 9. Okay, let's look at that. We have the number here and we have the square here. 1 or 9, right? So 1, we have 1. 9, we have 81, right? Then next is 11, we have 121. Next will be 19, which is 361, and we keep going. What do we see? For all the numbers that end with 1 or 9, the square always ends in 1. So what did we see in the previous slide? We saw that for all numbers that have last digit as 1 or 9, they have squares that end in 1, right? So we will just make a small note. For all numbers that end in 1 or 9 have squares that end in 1. Okay, now let's look at the squares for numbers whose last digit is either 6 or 4. So now we're looking at squares of numbers with last digit as 6 or 4. We have the number here, we have the square here, we have 4, square is 16. We have 6, the square is 36. We have 14, the square is 196. We have 16, the square is 256. And this keeps going on and on and on. What do we see? We see that for all numbers that end in 6 or 4, their squares are ending in 6, right? So now, again, what did we see? We see for all natural numbers, for all natural numbers that end in 6 or 4, or they have 6 or 4 at units place, the square ends in 6. Now let's look at some more patterns. Let's look at adding triangular numbers. Adding triangular numbers. What do I mean when I say adding triangular numbers? You'll see just in a bit. So when I say 1, this is just 1, right? When I say 3, we can represent 3 as this, and this as a triangle, right? And then we have 6, which we can represent. Then we have 10, which we can represent as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? We see that this is like a triangle every single time, right? Now it's saying adding triangular numbers. So if we were to combine two consecutive triangular numbers, what do we get? We will notice that we get a square. Let's see, if we were to combine 1 and 3, we have 1, 2, and 3, right? And then we have the 1 here. We get a triangle. Let's see if we were to combine 3 and 6, we will see that we have 1, 2, 3, 4, 5, 6, right? And then 1, 2, and 3. This was one triangle, and then this was the other triangle, right? But we get a square. And similarly, if we were to add 6 and 10, we will again end up having a square. We see that adding 1 plus 3 gives us 4, which is 2 square. Adding 3 and 6, we get 9, which is 3 square. Adding 10 and 6, we get 16, which is 4 square. So on and so forth, right? Now, let's look at 3 square equals 9 and 4 squares equal 16. Now 4 squared minus 3 squared is 16 minus 9, which is 7, right? Similarly, let's look at 4 square equals 16 and 5 square equals 25. And then 5 squared minus 4 squared is 25 minus 16, which is 9. And now let's say we have n and n plus 1. So we have n squared and n plus 1 squared. Therefore, n plus 1 squared minus n squared will be n squared plus 1 plus 2n minus n squared, 2n plus 1, right? We see that there are 2n numbers between squares of two consecutive numbers. We see that there are 2n numbers between the squares of two consecutive numbers. Now let's look at adding odd numbers, right? So the sum of first odd number. What is the first odd number? It's 1 squared, right? Now the sum of first two odd numbers, 1 and 1 plus 3, which is 4, which is 2 squared. Similarly, sum of first three odd numbers, 1 plus 3 plus 5, 9, which is 3 squared. Then sum of first four odd numbers is 1 plus 3 plus 5 plus 7, which is 16, which is 4 squared, right? If we keep going, then sum of first n odd numbers is 1 plus 3 plus 5 plus n equals n squared, right? Therefore, we can also say that if a natural number cannot be expressed as a sum of successive odd numbers starting with 1, then it is not a perfect square. Then it is not a perfect square. Okay, now let's look at sum of consecutive natural numbers. Let's start with 3 squared, which is equal to 9, which can be written as 4 plus 5, right? And then 5 squared equals 25, which can be written as 12 plus 13. Then let's look at 7 squared, which is 49, which can be written as 24 plus 25. We can keep going, so on and so forth, right? Now, let's look at the product. Now let's look at the product of two consecutive even or odd numbers. I'm talking natural numbers here, right? So let's talk about the product of two consecutive even or odd natural numbers. So let's look at 11 times 13. What is it? 143, which is 12 squared minus 1, right? We can write that as 12 plus 1 times 12 minus 1, right? Right? Now, Similarly, if we were to look at 13 times 15, what do we see? We see we have 14 minus 1 times 14 plus 1, which is 14 squared minus 1, right? And now if we were to look at 15 times 17, we will see it is 16 minus 1 times 16 plus 1, which is 16 squared minus 1. Similarly, if we keep going, we'll see at the nth entry, right, we have n minus 1 times n plus 1, which will be n squared minus 1. Okay, now let's solve some questions together. The first one that we have here is what will be the unit digit of the squares of the following numbers? Let's look at the first one here. That is 81. Now remember that we covered the fact that for the numbers that end in 1 or 9, or the numbers that have 1 or 9 in its unit place, have squares that end in 1, right? And for the ones that had 4 or 6 in their unit place, the squares ended in 6. We see that it is 1 here, right? This is ending in 1. Therefore, for numbers that end in 1 or 9, squares end in 1, right? Therefore, the unit digit of the square of 81 will be 1, right? Now, let's move on to the next one. Here we have the number at the unit place is 7, right? So let's try to check. So if the number is 7, it's 49. If it is 17, it is 289. If it is 27, it's 729. We keep going, right? We notice that for the numbers that end with 7 or have unit digit of 7, they have squares that end in 9. So the square ends in 9. So the unit number or the unit digit in the square of this number will be 9. Now let's move on to the last one for this question. We see it's 6. Again, we went through this topic before and we did cover, just like for the ones that end in 1 and 9, we covered for the ones that end in 6 and 4. And we know that for numbers that end in 6 or 4, square ends in 6. Therefore, the square will end in 6 in this case. Now let's move on to the next question. It says, squares of which of the following be odd numbers? Okay, the first one that we have is 431, right? The number at the units place we see is 1, right? Again, we know that for the numbers that end in 1 or 9, their squares end in 1, right? So since this number has 1 in its units place, its square will end in 1. Therefore, the square of 431 will be an odd number. Moving on to the next one. Again, remember in the previous question as well, which is right here, we discussed that for numbers that end in 6 or 4, the square ends in 6. Now this number has 4 in its unit place. Therefore, the square will end in 6, right? Therefore, the square of this number will be even. Now let's move on to the next question. Next question says, find the missing numbers using the given pattern. So we see here we have 1 squared plus 2 squared plus 2 squared equals 3 squared, right? And now we see the next one is 2 squared plus 3 squared plus 6 squared equals 7 squared. What do we, and then the next one is dash squared plus dash squared plus 12 squared equals 13 squared. Now, using these first two lines that have been given to us, completely filled out, let's see what the pattern is. We see in the first case, it's 1 squared plus 2 squared plus 2 squared is 3 squared. And the second is 2 squared plus 3 squared plus 6 squared is 7 squared, right? We see that we have 1 here and then we have 2 here, right? So this is almost going as 1, 2, 3, and then we see 4, 5, and 6, right? So this will definitely be 3 squared here, right? And then what is the next number that we see? The next number is the consecutive number, right? So after 1 we have 2, therefore 2 squared. In this line after 2 we have 3, which is 3 squared, right? So, and then even in this case we see after 4 we have 5 squared, right? So what will be the number in this case? It will be 4 squared, right? And now let's see how did they generate, like how was the third or this number generated? We see that 1 times 2 is 2, and we see that 2 times 3 is 6. And here we are also seeing that 3 times 4 is 12, right? Therefore, the next number will be 4 times 5, which is 20. Similarly, since this number is a product of these two, this will be 6 squared, since 5 times 6 is 30, right? And now for the last one, what will that be? We know that this has to be 7 squared, since consecutive, according to the pattern. Then this will be the multiplication of this, so 6 times 7, which is 42, right? What will be this number? We see that this number is always plus ones, right? From 12 to 13, 20 to 21, 30 to 31. So this one will be 43, right? There we go. Now let's move on to the next question. It says express 121 as sum of 11 odd numbers. Again, we did cover this topic in this very video, so you can probably just go back in the video and see how you can express a square as a sum of consecutive odd numbers. But for this one, 121, which is 11 squared, how can you express it as sum of 11 odd numbers? Let's start. It will be 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the last one is plus 21. If you were to add all of these numbers, you will get 121. You can check it on your calculator. And we have covered this in this very video. Just go back a little to see how you can express the square as sum of consecutive odd numbers. Okay, now moving on to the last question, we have how many numbers lie between 25 and 26? Again, we did go through this topic as well. For two consecutive numbers, we did find out that how many numbers lie between the squares of the consecutive numbers, and the formula was only 2n lie between two consecutive numbers, right? So we have 25 and we have 26, so 2 times n, because this is n plus 1, therefore 2 times 25, which is 50. Therefore, 50 numbers lie between squares of 25 and 26. Now the second part is 99 and 100. Again, this is n plus 1. Formula is 2n, so 2 times 99, 198. Therefore, 198 numbers lie between squares of 99 and 100. So this brings us to the end of our video. If you guys do like my videos, please do not forget to like and share this video. Also, please do leave a comment down below. Please do subscribe to my channel and hit the bell icon so you never miss a video ever again. If you guys have any other questions with regards to other math topics, please do not forget to leave them in the comments down below and I will get back to you on those as well. Bye for now.